Assalamualaikum and hello everyone. I am Aezal Muhammad Faim and would like to present a paper with the title A Review on Oxide Scale of Low Cost Titanium 6 Aluminium 4 Vanadium Substitution Alloy Composition. Titanium had been used in many engineering fields. Specifically, titanium 6 aluminium 4 vanadium composition, also known as Ti64, is the most commonly used in many industries. It's also known as workhorse of the aerospace industry. It mainly used as an aircraft airframe and also in engine compartment. It was used in 1952 by building the US experimental jet named Douglas X-3 Stiletto. In 1964, Lockheed SR-71 Blackbird aircraft is built mostly on titanium. This kickstart the titanium industries. Why Ti64 is being chosen? Because its property gave a high in strength to weight ratio, high in tensile and fatigue strength, high in corrosion resistance, and also biocompatibility. Titanium is expensive even though it is the ninth most abundant element, so it is rarely used in commercial purpose. Another properties of Ti64 is this composition is an alpha plus beta phase alloy. It is an alloy that is flexible to manipulate. The aluminium in Ti64 is a alpha stabilizer and the vanadium is the beta stabilizer. The vanadium is an expensive element, so in a low cost substitution, we substitute the vanadium with a much more lower cost beta phase element. This is a beta phase element that are much cheaper than vanadium. First, we got molybdenum, copper, nickel, chromium, iron, and also manganese. Oxidation is a chemical reaction between the metal itself interact with the oxygen mostly come from the atmosphere. When this oxidation occurs and a thin oxide scale form on the surface of the metal, this formation can roughly categorized in four steps. The first step is the oxygen is absorbed at the surface. Second, the formation of the oxide nucleation on the surface. Third, the lateral growth of the nuclei. And fourth, the formation of compact oxide scale on the surface. Here is the model of the formation of the oxide scale. Here we can see the atmosphere in a, is absorbed on the surface of the metal. Then we create a nuclei. The oxygen create a nuclei. Then the nuclei will laterally grow, and after it hits with each other, the, the growth is vertical, which increase the thickness of the oxide scale. If the oxide scale isolate the metal with the atmosphere, it will become an excellent corrosion resistant. As for Ti64, its corrosion resistance is not as good as commercially pure titanium alloy, but compared to other alloy, it is an excellent corrosion resistant. The oxide scale that form on the surface is mostly titanium dioxide in a rutile form. This oxide, when damaged, either penetrate or broken, the oxide layer will quickly reform, which ensuring the protection of the metal to the atmosphere. As a review on past research, first we got Fuji and Takahashi in 2002 with a 5.5 aluminium and 1 weight percentage of iron. We observed that the formation of titanium iron precipitate was observed at high temperature oxidation at 450 degrees centigrade for 100 hours. Then Yoon et al. In 2011 with a composition of 1 weight percentage iron and 4 weight percentage iron. Both alloy composition shows a superior corrosion resistance compared to Ti64. Another one is Atapor et al. In 2011 with a composition of titanium 8 aluminium 1 molybdenum and 1 weight percentage vanadium shows that weight loss tests in 5 molar hydrochloric acid solution indicate that this composition exhibit a inferior corrosion resistance compared to the TiC4. Another paper is in Simsack and Oziurek in 2019 with a composition of 5 weight percentage aluminium and 2.5 weight percentage iron. It shows that it has a higher corrosion resistance. Then Kim et al. In 2003 with composition of 4 weight percentage iron shows that after being exposed to the high temperature of 700 degrees centigrade, the grain size of the alloy has a higher volume for beta phase element, which is iron. Another paper is Lu et al. In 2016 with 1 weight percentage iron, 2 weight percentage iron, and also 4 weight percentage iron. The experiment is done on electrochemical corrosion test, shows that several forms of titanium oxide form, form rapidly on the surface with iron addition once it is immersed in the electrolyte. Last but not least, the Bondorin et al. In 2018 with a composition of 4 weight percentage iron, it shows that there are no titanium iron oxide occur on the surface of the metal. In conclusion, for improving the Ti64 properties, researcher is much more prefer to the adding and coating of the composition rather than substitute the element. In terms of the low cost approach, the substituting the vanadium with iron is much more favorable to its corrosion resistance. Other low cost elements perform well in other properties, mainly in hardness, but not in corrosion resistance. That's all. Thank you.